In this next section, continue with solving trigonometric equation. We're going to talk about taking the square root of both sides, meaning the same thing as taking the square root of each side. Now, this doesn't apply to all equation. When we're taking the square root, we're trying to get rid of the square so that you would have an individual trig function. But taking the square root won't apply to all because sometimes you might have to factor out. So be mindful of what type of equation you have. You'll see when in these three examples that we're going to cover, you will know when to square root and then the other equation when to factor. So in this first example, we have 1 plus sine square of x equal 5 sine square of x. So what we're going to do is try to get all the trig function with the x by itself and then have all the numbers on the other side. Now taking a look, we see that there's only one number, which is 1, and it's on the left side. So that means I'm going to try to get rid of sine square x from the left. So in order to cancel out sine square x, I'm going to write minus sine square x on both sides. One equal 5 sine square of x minus sine square of x will become 4 sine square of x. And then if I need to get sine square of x to be by itself, I'm going to divide by the 4. So I'm going to have 1/4 equal to sine square of x. Now, what you can do is you can flip it since sine square of x is by itself now. So instead of 1/4 equals sine square of x, I'm going to write it as sine square of x equal 1/4. Now, we're almost done. We have sine square of x and we just need sine of x. So since there's a square, it's by itself and then we have a single number on the other side. We're going to take the square root of both sides. Remember, if I do the square root on the left, I gotta do the square root on the right. So I'm going to write it over here for more room. So the square root of sine square of x will simply be sine of x. Now remember, when we take a square root of a number, always include plus and minus because there's going to be two answers. Now, to review from 5.1 and 5.2, if you have a square root of a fraction, you can rewrite it as plus and minus the square root of 1 and the square root of 4. So, sine of x equal positive and negative 1/2. So that means we need to find the value of x, the angle measure, when sine of x equals to 1/2 and sine of x also equals to negative 1/2 because that's where we got it from, positive and negative 1/2. So that means in this case, instead of 2 answers, we may need more than 2 than the usual amount. So this is where you would refer to your unit circle. So it's like what angle measure where sine of x equals to 1/2 and negative 1/2. Now bear in mind when we're looking at the exact values, the values for sine is typically the one on the right. So what angle measure? So if I were to write it in degrees, the first one would be 30 degrees. And then as I'm examining my unit circle, the second one will be 150 degrees. Now that's for the positive 1/2. Now examining the angle measure for negative 1/2, as I'm doing continue with degrees, there's one at 120 degrees, and then there should be one more which is at 210 degrees. So this would be the answer that you would give me if I asked you in degrees. Now if it were in radians, the radians for 30 degrees, or I should say the radians equivalence for 30 degrees is pi over 6. The radians equivalence for 150 is 5 pi over 6. Now these two are for positive 1/2. Now for negative 1/2, the radians equivalence for 120 degrees is 2 pi over 3. And then the radians equivalence for 210 degrees is 7 pi over 6. These two radians are for negative 1/2. So in this example, we actually have 4 answers for degrees and then 4 answers for radians. So bear in mind, when you take the square root of any number, you must include plus and minus unless it's specified from the very beginning if they're only looking for negative answers or positive answers. So when you take a square root, must include plus and minus unless it was specified otherwise, if they were looking for just positive only or negative only for any given trig function. But if it didn't specify, that means that plus and minus, possibly 4 answers, just like in this example. In our second example, we have negative 4 plus 2 cosine square of x equals to negative 3. So we have one trig function and then 2 numbers. So what we're going to do is try and get all the numbers on one side. So since my trig function is on the left side, I'm going to get rid of the negative 4. So let me repeat, I have one trig function and it's on the left side of the equal sign. So I'm going to have all my trig function of x on the left. So anything that's not a trig function with x, which is this negative 4. So I'm going to cancel out the negative 4 by adding 4 to the left and then to the right. So I'm going to have 2 cosine of x equal negative 3 plus 4 will be 1. Now to get cosine square of x to be by itself, I need to get rid of this 2 by dividing. So we're going to have cosine square of x equal 1/2. Alright, we're almost finished getting cosine square x to be cosine x. Now, to get rid of that square, where it changes into cosine x, we're going to do the square root of both sides. We're going to have cosine of x equal plus and minus square root of 1/2, which will become positive or negative 1 over square root of 2. Alright, so I'm going to write up here because we have a little bit more work to do. Alright, so we have 1 over the square root of 2. Now as you recall, we cannot have a square root in the denominator, so what we're going to do is rationalize it. So when we multiply square root of 2 to the numerator and the denominator, it will be square root of 2 over 2. So we're basically looking for the angle of x when cosine of x equals to positive and negative square root of 2 over 2. Alright, so again I'm gonna write it separately, one for positive and one for negative. So this one will be positive square root of 2 over 2, and then the other one will equal to negative square root of 2 over 2. Alright, so now we're going to look what angle measure when cosine of x equals to positive square root of 2 over 2. As you recall, square root of 2 over 2 typically deals with 45 angles. So there's one in quadrant 1, so 45 degrees. And then for positive, then there's another one in quadrant 4 because the x value is positive. So in quadrant 4, the degree is 315 degrees. Now if we're doing negative square root of 2 over 2, then there's actually two. One in quadrant 2, which is 135 degrees. And then the other is in quadrant 3, which is in 225 degrees. So we got the 4 degrees for when cosine of x equals square root of 2 over 2, and when it equals to negative square root of 2 over 2. Now, if I were to ask you the radians, so the radians equivalence for 45 degrees is pi over 4. The radians equivalence for 315 degrees is 7 pi over 4. The radians equivalence for 135 degrees is 3 pi over 4. And then the radians equivalence for 225 degrees is 5 pi over 4. So there's my answer for radians. So if I ask you in degrees, it's these four: 45 degrees, 315 degrees, 135 degrees, and 225 degrees. Now, if I ask you for radians, it would be pi over 4, 7 pi over 4, 3 pi over 4, and 5 pi over 4. Now the order does not matter as long as you have all of them. If you don't, then you would lose partial credit, say if this was on a given test or a given quiz. In this third example, we have 3 tangent square of x minus 1 equal to 0. So try to get tangent square of x to be by itself. What I'm going to do first, cancel out the minus 1 by adding 1. So now we have 3 tangent square of x equal to 1. And now I'm going to divide both sides by 3 to get tangent square of x equal to 1 over 3. So once I get to tangent square of x, the only thing I have left to do is take the square root on both sides. So it will become tangent of x equal positive and negative square root of 1 over 3. Now I'm going to write up here for more room. Well, actually I have to have more. So tangent of x equals positive and negative square root of 1. Well, the square root of 1 over 3 would become positive and negative 1 over square root of 3. Alright, so what I'm going to do is I'm going to write up here and then simplify that. So we have tangent of x equal positive and negative 1 over square root of 3. When we simplify it, taking this, rationalizing the denominator, multiplying top and bottom by square root of 3, would be square root of 3 over 3. So positive and negative square root of 3 over 3. Alright, now here's the problem we have with the unit circle. The unit circle only gives us an sine and cosine. So how do we find tangent? Well, as we recall from 5.1 trigonometric identities, the only one that applies to tangent, sine, and cosine is the quotient identity. So tangent of x equal sine of x over cosine of x. So in order to find where tangent of x equals square root of 3 over 3, more simplistically, where it's 1 over square root of 3, that's where you have to look for it. So you would look at the unit circle. Now, how would you figure it out? You would have to take the sine values, the sine exact values, and divide it by the cosine exact value. Now, I wouldn't mess with the 1 and zeros because they either give you 0, 1, or undefined. So we can exclude the 0 or 360 degrees, 90 degrees, 180, and 270. So that means that you have to look at all the other ones, and there's a total of 12 angles. So that means basically finding the tangent value 12 times. But that's too much work. So we're just going to look at the ones that have square root of 3. So we're going to look at each angle that has a square root of 3 in it. So for example, let's take a look at 60 degrees. So at 60 degrees, sine of 60 will be square root of 3 over 2. And then cosine of 60 will be 1/2. So basically this is the coordinate. So 1/2 and square root of 3 over 2. This is 60 degrees. Now we're going to see which one matches with 1 over square root of 3. We're going to ignore the plus and minus for the moment. So here it's a fraction divided by a fraction, so we're going to rewrite it as a division of fraction. Square root of 3 over 2 divided by 1/2. Then multiplication, which will simplify into square root of 3 over 1, which is square root of 3. Now that does not match with that. So we're not going to do 60 degrees. Now that means we're going to ignore where it's 1/2 first and then square root of 3 over 2. So we're not going to use 60. But let's see if we could do 30 degrees because it has a square root of 3 in it. So we're going to do 30 degrees. Sine of 30 degrees is 1/2 on the top. And then cosine of 30 degrees is square root of 3 over 2 on the bottom. Rewrite it as a division of fraction. Change it to a multiplication of fraction. And that will equal to 1 over square root of 3 over 3. So it matches with this one. So the coordinate that we're looking for, or the arrangement, is is this. So on the unit circle, you're going to look where square root of 3 over 2 comes first, and then comma, and then 1/2. So since we're doing for positive and negative, this is where now we bring it back. We're doing, and we're looking for positive and negative 1 over square root of 3, which essentially is the same as positive and negative 3 square root of 3 over 3. But basically we're going to look for the positive ones and the negative ones. So I'm going to erase to make more room. So the only one that has square root of 3 over 2 comma 1/2, while tangent is all positive and negative, there's actually 4, 1 in each quadrant. So the first one is what we just did, 30 degrees. And then looking for the same arrangement where it's square root of 3 over 2 and then 1/2, I see that we have another one at 150 degrees. And then continue to look for the same arrangement. There's another one at 210 degrees. And then there should be one more in quadrant 4, which it is at 330 degrees. Now, if I were to ask you in radians, so the radians equivalence for 30 degrees is pi over 6. The radians equivalence for 150 degrees is 5 pi over 6. The radians equivalence for 210 degrees is 7 pi over 6. And then the radians equivalence for 330 degrees is 11 pi over 6. So we have 4 answers in degrees. And then we have 4 answers for radians. So it's the same as the other example, 4 answers. Now what's different about this example is that we did with tangent, so you had to do a little work recalling from the identities for tangent, because the unit circle only gives you the exact values for sine and cosine, where if this example we're asking a tangent. So you just have to think about it in depth, which one can give you 1 over square root of 3. So which arrangement, which degrees, which radians, which angle measure will give you, where when you simplify using the quotient identity for tangent, that gives you 1 over square root of 3. And that whereas where you have to do some extra work to find it. Once you figure out which one, then going from there will be easy. So keep in mind that when we're solving with trig equation, you still have to remember your unit circle and your trig identities, because we're going to continue using trig identities, especially when we're going to move on to the other sections such as factoring.